Hi friends, you're welcome back to Olafem Physics class tutor. Um, this is the continuation of Waec Physics by 2025, which I promised you that I'll be doing solving. Now, in this section, it contains two, as in two questions I'll be answering here. So I need you to take your time. I mean, take your time very well because of the questions, the kind of questions that is being asked here. So it's in two folds. All right, let's go. Question 17. We have question 17 and then question 18. So question 17 says the current passing through the 6 ohms resistor is 1.5 amperes. Calculate the current in the 3 ohms resistors. Now, this is a case of a an electricity. Okay, so here we are asked to find a current in the 3 ohms resistor. If in this diagram, if you look at this diagram, you will see the connections, how the connection is being done. Okay, this is the EMF, the cell. This is the resistor connected in parallel, and this is in uh 6 ohm resistor, okay, in series here. So now the first thing we need to do is that the question says calculate the current that is here, and in the questions already know that the current passing through the 6 ohm resistor is 1.5 amperes. So the current passing through this is 1.5 amperes, right? Now, how do we now know the current that is we pass here? All right, first and foremost, solution. We know that conventionally that current flows from the positive terminal to the negative terminal. It moves from here then back to here. But for the electron, it moves from here, from the negative terminal to the positive. So now, because we are dealing with currents, so that is what we are going to do. So it is supposedly, know that the current flows from here and then enter here and then here. But how do we know? This is what we are going to do. We before we can get 1.5 as in 1.5 amperes here, so we need to know we need to do we need to combine this resistor together. No, they are in parallel. So by combining them, total the equivalent resistance in parallel is taken to be 1 over 3 plus 1 over 2, which is equal to, find the SCM, and that is the SCM is 6. So this is 2 plus 3. So this is 5 over 6. So uh, R, RT or R parallel, okay? Let me use the parallel. Let me use this one, okay? R parallel is 6 over 5, which is 1.2 ohms. All right. So it now becomes like this. The circuit will now be reduced to this. Okay. The circuit will reduce to this. So this is 1.2 ohms, and then uh, 6 ohms. What are we finding? We said we want to find the current. Or the first thing is that we need to find the potential, as in the potential difference. Okay. the potential what difference, that is the voltage uh, supply to this circuit. Okay, the PD, okay, supply to this circuit. That is the first thing we need to find. So now here we go. So by finding yeah, we have reduced it now. Now it now what 1.2 ohms is now in what in series to what in series to 6 ohms, whereby uh we assume that we know that in series connection the same current what flows through in this RC, I mean in a resistor in series. So but before that, let's first of all know the voltage supplied to the whole circuit. So let's do the R series of this. I'll say that will be 1.2 plus 6, which is 7.2 ohms. So now it has now reduced to the circuit has now reduced to what? To this. All right. So it has now reduced to this seven. The whole thing is what? 7.2 ohms. So what is the current? The current is 1.5. Okay, it's 1.5. So now, what will be the potential difference across it? So from Ohm's law, you say that it is V is equal to IR. Or you can use what we call it, E is equal to IR plus IR. But neglecting the internal resistance, so that will be zero. So it will become IR here. So it's still the same thing. So now V, the potential difference now is that was a 1.5 times 7.2. So 1.5 times 7.2, if you press your calculator, that will give you 10 point, uh, 10.8 volts. That is the potential difference, the terminal potential difference supplies to the whole circuit. But we are here to find the current that will pass through this through 3 ohms resistor. So now let's now go to the main, I mean to the what we are asked to do. Now, so far we have found the potential difference, the terminal PD across the whole circuit. Okay, we all know that you will agree with me that the potential in series potential difference, the PD to each resistor is different. Okay, is what is different. So there is a potential one divider here. All right. The PD across this will be different from the PD across this, but the same current will pass through. That is in series networking, in series circuits. So now, what is the PD across 6 ohms resistor? So the PD across 6 ohms resistor, that is from here, V is equal to IR. All right. So and your your current is still 1.5 times R, which is 6. Okay, by the time you multiply it, that will give you 9. I think I'm still correct. Okay, yeah. So that will give you what? 9 volts. So this place will be 9 volts. So if this place is 9 volts, what will be this place? Okay, don't mind the space. So that will be 10 minus 8. That will be 1.8 volts. Okay, so that means that 1.8 volt is supplied to this 1.2 ohms, while 9.0 supplies to 6 ohms here. Now I think we are moving gradually. So now let's now uh, bring it here, 9.0 volts, and this is uh, uh, 1.1.8 volts. Okay, And in a parallel connection, okay, for every parallel connection, the same voltage that is applied here will be the same voltage that will be applied to the other load or resistor. Do you get me? That is in parallel connection. Okay, in parallel connection like this, I don't know, maybe I've seen something like this. All right, parallel connection. When you have a parallel connection, all right, like this. Okay, all right, you have a parallel connection like this. Let's say V1. I mean, let's say uh you have R1, R2, R3, and then you have been supplied with a voltage across. So the same voltage that is applied to the V R3, okay, will be equal to that R2 and will be equal to R3. So they have the same voltage. So that is what I'm trying to explain. So in that case, okay, in that case, that means that our problem is what is already solved. So that means that this one is taking a voltage of a potential difference R3. R3 is taking a potential difference of 8 volts. 1.8 volts. So what will be the current, which is what we are looking for here? So the current now from Ohm's law, we have V is equal to I R. So I is equal to V over R. So what is your V? 1.8. What is your R? Which is what we are looking for. Okay, that is 3. So by the time you divide 1.8 divided by 1.3, that will give you 0.6 ohms. Okay, so and we can also check for this. Okay, that for the R3, R2. So that will be 1.8 divided by 2, which is 0.9. So if you divide this one, if you have this current with this one, you're going to get a 1.5. I'm just explaining it further. Okay, you're going to get 1.5. Okay, 1.5. And mind you, it is 1.5 that is being supplied. That our 6 ohms resistors as. So you can see that we are still what we are. We are still correct. 1.5 we go. We move here. 1.5 we comes from here, enter here. This one we share is 0.6 amperes. This one we share 0.9 amperes. Then combined again, that will be 1.5, and 1.5 flows here. Then come here and enter. That's how the whole things goes. I think from here now, need for me from the question. Question 17 is what uh 0.6. That is D. While question 18, that is C. I think if you find this useful, please don't forget to share, to comment, and to follow this channel for more. Thank you.